Hello guys, uh, my name is Kalyan Kumar. Today I'm going to make you understand about the error time limit exceeded. You might have seen this error while solving the problems in coding platforms like CodeChef, CodeForces, InterviewBit, LeetCode, everywhere. So actually what I wanted to tell you is today I'll be showing you how this error is generated and how we have to uh, make it corrected. So first of all, I wanted to tell you to understand this time limit exceeded error. I should make you understand about uh, the program execution and time complexity issues. For example, guys, I wanted to make you understand with a problem called say counting divisors. Okay, counting divisors for the given integer n. Okay, given integer n. So I will not be writing the any language specific code, but I will write it in a pseudo code. Okay, I'm just taking a pseudo code where this will be the pseudo code for the problem counting devices for the given integer. See, counting devices means, for example, if you take n value, say 48. So what are the divisors for the given value 88, 48? Let us decide what are the divisors for the given n value 48. So 1 is going to be divisor, 2, 3, 4, 5 is not a divisor, 6, 8, next 12, next will be 16, and next 24, and next 48. And if I count it, 1 2 3 4 5 6 7 8 9 10, so we got total 10 number of devices, n value 48, and we got 10 devices. For this, if I wanted to make any code or otherwise pseudo code, what I will be doing is, guys, i will I will be taking a loop where I value starting from say 1 to given value n. Assume that a loop is started where I value is starting from 1 and going up to n, where n is included. Okay, I'm just considering that n is included. So if I go further, I wanted to check by a condition called if n mod I is 0, then I can say that I is going to be the divisor for n, right? So now if it happens, what I will do is for each value of I am checking whether I is a divisor to this n or not. So I can make a count. So maybe I have declared the count variable as and initialized the count variable as say 0, and I will increment the count here. Correct? Now if I do that, what is going to be happening is my loop is starting from 1 and going up to n, and each value in between this is getting operated in this operation n mod I. Suppose if I is a divisor to this n, the remainder is going to become 0. So if it is equated to 0, I can say that I is the divisor for n. So I just wanted to increment the count. Guys, just assume that if this is the pseudo code, if this is the algorithm for counting the number of devices, now I wanted to do some analysis part for this code. Okay, let us check that. See, very simple. If I really wanted to make the count of the devices, what I will be doing is I wanted to count the number of operations happening here, right? I wanted to make the count of the number of operations. What I will do is here, I will be counting the number of operations. See, as this is one operation, right? And here some iterations are happening now. In these iterations, I wanted to check. See, guys, I equals to 1 to n na? So maybe this loop will be written like I starting from 1 and I going up to n, and I will be incremented. So this might be the loop you will be using, either maybe C, C++, or Java. And even Python also, not might this might not be the syntax, but this will be the loop you will be using, right? I just wanted to make a count, so count of operations. So that is why. So I equals to 1 is one operation where this is happening for only one time in the entire program, and I less than or equals to n. This condition is going to be checked for n times, because see, the I less than or equals to n means I is incrementing for every time and wanted to check whether whether this I is smaller than n or not. So this condition is getting checked for n times in this for loop, right? So this is happening for n times, and I plus plus is going to be happening for again. This I plus plus is nothing but incrementation of I is happening for n times again, because a loop has to iterate, right? So if I look at this here, this for loop is actually happening uh, where this statement is only for one time and these are all for n times. Now if I go inside, n mod I equals to 0 uh, is something like na, n mod I is one operation, and the result, right, whatever the result comes here, that result is getting checked with the 0. So this is one operation. So I can say that this is one operation and this is one operation happening for n times in the for loop. So this is n times and this is n times. Now count incrementation is happening for maximum if all if condition is if this condition is becoming true, this count can be incremented for n times again. So this is n again. So I can say that let's count one more time. I'll change the color here so that you will understand very well. Say let's take orange or red. Let me count. This is one time happening, and in this for loop I can count it here 1 n n 2n plus 1 times 2n plus 1 times operations are happening here. So I can say that 2n plus 1 here, and inside this for this condition two things are there, right, n and n. So 2n times here again, and this count plus plus is again n times. So total operations here happening like 1 plus 2n plus 1 plus 2n plus n, and total like 5n plus 2, right? So this is the polynomial. I can be able to say that this polynomial is nothing but the number of iterations number of iterations happened number of iterations happened in the pseudocode, or otherwise let it code. Number of iterations happened in the code is 5n plus 2. Now guys, we have a lot of work to do, like analysis on this code. Let us do that. See guys, we found like number of iterations is 5n plus 2, correct? Guys, what would be the maximum value that we can take for n? That we have to decide when we see the question, right? See, the question is something like this: counting the divisors for the number of divisors for the given integer n. And here I am giving you the constraints for the n. Say n is an integer, so maximum and minimum values can be, I wanted to give for n as 1 is going to be the minimum value that I wanted to supply for n, and n can go up to the maximum value, say 10 power 9. Okay, n value is going up to 10 power 9. Now let's consider this as our constraint, and let's work out something here for the polynomial that we have defined. Number of iterations here are 5n plus 2. Guys, n can be maximum and minimum values are there. N minimum can take only one value for n. Maximum can take up to 10 power 9. So there is no problem. There is no point in taking the value for minimum, because if it is minimum 5 into 1 plus 2, 7 iterations, that doesn't going to be a big task for the computer. So what I'll do, I'll take the maximum value. And if n is say 10 power 9, it means that 5 into 10 power 9 plus 2 number of iterations happening for your computer. Iterations happening for your computer, right? Now I wanted to make you one more question, like what is the capacity of the computer? How we are going to be measuring the capacity of the computer? In terms of clock speed? Yes or no? in terms of clock speed. Now, what is clock speed actually? The clock speed is nothing but number of operations or instructions, right? I can say operations or instructions executed by executed by computer computer in a second. Okay, I have to say that number of operations or instructions executed by computer in 1 second is nothing but in 1 second is nothing but clock speed is nothing but clock speed. Yeah, correct. So now let me mark it as something as we have worked out, right? So okay, fine. Mhm. Now, so we understood that clock speed is nothing but the number of operations that are executed by computer in 1 second. So if I wanted to make you understand, guys, my computer, my laptop is actually 3 point gigahertz. Guys, I'm telling you, this is going to be more interesting part. So try to hold on. 3.08 gigahertz is the clock speed of my computer, which means that 3.08 giga means 10 power 9, hertz means per second, which means 3.08 into 10 power 9 instructions per second is executed by my laptop. 3.08 into 10 power 9 means, can I say 308 into 10 power 7? 10 power 7 is nothing but 100 crores, and if I multiply them, oh, sorry, not 100 crores, it is 1 crore. So 308 into 1 crore means it is going to become like 308 crores instructions per second. If my computer is capable of executing 308 crores of instructions per second, now the interesting part comes. Just try to be more focused. Okay. The above program, what I have written, is having the number of iterations like this. Polynomial is 5n plus 2. And if I consider n as maximum, okay, n as maximum, maximum means 10 power 9. 5 into 10 power 9 plus 2 iterations are happening in the program. Iterations are happening in the program, in the code that I have written. Okay. Now 5 into 10 power 9 plus 2. Plus 2 we can neglect, man. So 10 power 9 is nothing but 100 crores, which means that 500 crores of instructions are iterations. Let me change it. 500 crores of iterations per second are being generated for my program, for my code, which I have written for the device, counting devices, right? So now let me make you very clear, guys. I have given you the clock speed for my laptop, but I'll tell you, when we are working with the coding competitive environment, competitive coding environment, in that environment, uh, every coding platforms will have a hardware capacity of will have a hardware capacity of, say, 1 gigahertz. Okay, 1 giga means 10 power 9 per second, which is nothing but 100 crores of instructions or operations per second will be executed now. Let me repeat, guys. I wanted to make a summarization. Don't get confused. First point: total number of operations in code is 5 into 10 power 9 operations per second. Sorry, not per second. Let it be, it is like 5 into 10 power 9 operations. Now, online coding platform capacity, online coding, okay, hardware capacity, hardware capacity is found like 100 crores. So which means that 10 power 9 operations per second. So if your computer is capable of, I mean to say, online computer, online computer is capable of executing the 10 power 9 operations per second. Just imagine, 10 power 9 operations per second. If this computer is required to execute the above code, how many seconds it will take? So I can calculate time taken to execute the code is 5 into 10 power 9 divided by 10 power 9 operations by operations per second. So I can say 10 power 9, 10 power 9 cancel, operation cancel, which means that 5 by 1 by 1 by second is nothing but 5 seconds. So I have to conclude in this way. Let us go back to the program. Here is the program code, and this code is having 5n plus 2 iterations. 5n plus 2 iterations. Okay, 5n plus 2 iterations. Where if n is maximum, 5 into 10 power 9 iterations, to execute this by 10 power 9 per second clock speed computer will take 5 seconds. Guys, see, if you are writing this code in C++, C++ code must be executed in 1 second, Java code must be executed in 2 seconds, Python code must be executed in 3 seconds as per the coding compiler's policies. Now you tell me whether this code, the code which I have written over there, will be executed. Suppose if I write it in C++ or Java or Python, whatever. Can you tell me, guys, if your coding compiler is giving you 1 second time and your code is taking 5 seconds to get executed, whether your C++ language, if your C++ code, can it be accepted? No, because 1 second time is there, your code is taking 5 seconds. And you see Java, for Java also, the time is given like 2 seconds, but your code is taking 5 seconds. So Java is also not accepting. Python, you look at this, 3 seconds is given, but your code is taking 5 seconds. So again, I can say that the code is not acceptable. Now what has happened? For sure I can say that my code, whatever the code I have written here, that will be generating the time limit exceeded. Guys, I can say that this error, in short, we are going to be calling like TLE. Okay, time limit exceeded is happened because 5 seconds for this program has happened, whereas C++ is giving only 1 second, Java is giving 2 seconds, Python is giving 3 seconds, but still it is taking 5 seconds. So that is why this code is taking time limit exceeded error. Right? Hope you understood very well about this. If you have any queries now, what you can do is just try to pause the video and go back to the place at a particular slot where you have not understood. Repeat the video and try to understand it. Okay. So now the most interesting part again. If the code is not um, acceptable because of the time, so we are getting time limit exceeded. Now how to rectify, how to rectify TLEs, right? The most efficient way, not the efficient way, the one and only way, because TL is required to be like your code has to be executed quickly. That's all, and within the allocated time frame. So for that, the one and only option is optimization. You require to optimize your code. How you will optimize code? Simple. Let us see your number of iterations are 5n plus 2 na? And in this case, if you find out the big O time complexity in terms of the big O notation, so it will take what? Neglecting the constants, neglecting the coefficient of higher order term, Now leftover is n order of n. This order of n is not able to take this order of n is not able to uh, get executed or get submitted, accepted by coding platforms. So we require to reduce it. We require to reduce it. So let us reduce it. Actually, let me make you a small correction, guys. If it is like, yeah, fine. Anyways, that no correction. Correct. It's absolutely going well. Um, Now, suppose if I wanted to correct it, how can I correct it? Let's change the code to this way. I wanted to give you one more pseudo code, guys. Pseudo code. I know that if n is say 48, see this, guys. If n is 48, what are the divisors? 1, 2, 3, 4, 6, 8, 12, 16, and 24, 48. If you observe here, what is the square root of 48? What is the square root of 48? This will be somewhere, since it is less than 49, I can say 6 point something. If I wanted to get the sealed value of 48, that is neglecting the real value, you will get 6 here, right? Now you see here, up to up to 6, okay, up to 6, like 1 2 3 4 5 6, up to 6. How many divisors are there here? If you observe, exactly half divisors here. Even you can check for the any other number. Let's take n value, say 72. What are the divisors for them? 1 2 3 uh, 4, yeah, 4, not 5, 6, next 7, 8, 9, and 12, and 18, and next 24, 36, and 72. And what is square root of 72? This is something like more than 64 and less than 81. So this will be like 6 point something. No, 8 point something. Sorry, 8 point something. This 8 point something, we will neglect this something, only 8. And you see, up to 8, how many elements are there? 6 here and 6 here, right? So exactly half. I mean to say, um, uh, in the total number of count, we have half of the numbers before square root of that value. So which means that I can say that, um, if I can search the up to the square root of n, if I get say some x number of divisors, if I multiply this with 2, this could be the total number of divisors, total number of divisors in n, for n, sorry, not for n, for n, isn't it? Now we got it easy. Now how the pseudocode will be changed? Let's make it. Count is 0. Very good. Let me take for I starting from 1, I going up to square root of n, I plus plus. I took, I am taking including this square root of n, and inside this, if n mod I is 0, then let's take count plus plus. That's it. Now what I have to do finally, while returning the answer, I have to return double of the count. But actually, guys, there is a small point which we are missing here. If your n is say 64, which is a perfect square, if n is 64, which is a perfect square, the values will be, I mean, divisors will be 1, 2, 3. Is 3 divisor? No. 4. 5 is not a divisor. 6 is no. 7, 8. Next, Next will be 12, no, 14, no, 15, 16. 16, next 32 and 64. And if you observe, square root of 64 is 8 now, and we are taking the inclusion of 8. And if you see here, we are getting 4 here, we are getting 3 here, which means we are getting one shortage here, right? If it is a perfect square, we are getting one shortage. If it is not a perfect square, then I can say that double of the count, right? So I have to return basing on the perfect square. So what I'll do is I'll write here is n is a perfect square. Okay, I'll write is perfect square is a function. I'll check for whether n is a perfect square. If it is a perfect square, I can say the return statement like return twice of the, oh, if it is a perfect square, what it is to be returned, 2 times of count subtracted with 1, otherwise 2 times of the count is to be returned. Hope you understood well. Now, if you are having this code, let us find out the number of iterations and let's find out the total time taken for getting executed this code. So this is one instruction. Let me change the color. Yeah, one. This is one instruction, and inside this is one, and this is n. Sorry, square root of n, right? This is square root of n, and this is also square root of n. And again, n mod I will be 1, so that is like square root of n, and again which is equals to 0, again square root of n, and count plus plus is happening for square root of n times, right? Now if you see this returning also, of course it will take is perfect square also as a time count, but I am not looking at that part. Okay, considering that everything is happening in the single line, I'll be considering this as 1. Okay, now, if you come for the total number of iterations happening here, 5 times of square root of n plus 1 is the iterations, right? Which means I can neglect the constant and I can neglect the coefficient also. Now, square root of n iterations are expected in the code. Yes or no? Right. Now if n is maximum, 10 power 9 square root iterations are happening, correct? Now square root of 10 power 9 will be like somewhere around uh, 10 power, even if you consider maximum 10 power 10 also, na, this will be somewhere less than 10 power 5 only, right? Less than 10 power 5 only. The answer which is required for square root of 10 power 9 will be smaller than the 10 power 5. That's what I mean. I am considering the maximum limit here, so 10 power 5. 10 power 5 iterations, right? Very clear, na? 10 power 5 iterations, correct? Even if you consider here 5 multiplied by something is going to be happening here. Not a problem. 5 into 10 power 5 is also not are going to be number of iterations. Even if I consider the maximum limit, I'm going to have 5 into 10 power 5 iterations are happening. 5 into 10 power 5 iterations are happening. Now, let's come back for the number of instructions that can be executed by online compiler is 10 power 9 operations or iterations. Okay, anything okay. I have to change this also, operations. I'm sorry, operations per second. Now, if I wanted to find out time taken for executing the code is, time taken for executing the code is something like 10 power 9, 5 into 10 power 5 divided by 10 power 9, operations by operations by second. So operations will get cancelled. 10 power 5 will make 10 power 9 as 10 power 4, which is like 5 by 10 power 4 seconds, which is nothing but 0.0005 seconds, right? Now you have to be very clear about it. The approach, say, let me call the approach which I have discussed first, let me call it as approach 1, and the one currently what we have discussed is, say, approach 2. Two approaches are there for the solution for the problem counting number of devices. Approach 1 is taking 5 seconds to get executed, whereas approach 2 is written to get executed by within 0.0005 seconds. Now tell me which is more effective, more efficient. This is less efficient and this is more efficient approach. So guys, remember while writing the codes for any problem, you must be very careful about uh, getting the solutions within the acceptable time frame. So be cautious about writing the codes as optimized. Optimized codes only will be accepted by your coding compiler. So hope you understood well and enjoyed the session. Uh, if any kind of questions are there, you are free to ask. Thank you very much.